Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is course schedule. So let's go to LeetCode. There are total of num courses you have to take labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites at ith index basically represents two value a and b that indicates that you must take course B first before you want to take course A. So for example, pair 0 and 1 indicates that in order to take course 0, you have to first take course 1, finish it. That 1 might have more dependencies, so you should finish those first, and then you can take 0. Return true if you can finish all the courses, otherwise return false. So let's understand. Problem is pretty clear, and you can already if you're in college, you can relate that there are some prerequisite courses. For example, if you want to take data structure, then there is this discrete mathematics course. At least for me, it was a dependency, and I had to take that before I could take this data structure and algorithm course. And before I could take further courses, there were some other requirements. All right. Well, that's a different thing, and that's what we are actually trying to solve here. So here I have drawn, I've taken basically, and this is absolutely wrong. There are 5 courses. There are 5 courses that we are going to take, and we have to return that if we can finish all the courses. Now, prerequisite here represents these dependent courses or prerequisites basically. So here A and B, it means there is an edge going from A to B and finish course B before A. Okay, maybe you understand what we are talking about. Now let's go through this example and see if we can finish these set of courses. Now in prerequisite we have 0 and 1, so that means in order to take 0 we have to take 1. Now in order to take 1 we have to take course 3. In order to take 3 you have to take 4, and in order to take 1 you also have to take 4. So that means you have to take course 4, then you can take course 3. Because you have already taken both of these, then you can safely take 1, then you can also take 0. In order to take 0, you have completed these set of prerequisite, but then there is one more prerequisite, which is 2. Then you have to take this, and then you can say that you can take 0 as well. And now you can see that you have taken all the courses, and finally you can return that all the visited nodes are equal to basically the total number of courses given to us. So here we will basically use DFS, and what we are really trying to do is we are going to visit all the nodes and all the neighbors that it has before marking that node visited. We will visit its neighbors, and that neighbors all the other neighbors of that particular neighbor, and then we will mark that basically visited. So what we are really going to do is we will have let's say a map to basically, first we'll create a graph that will hold the adjacency list. So this is what we're going to create. I'll have graph that will store all the neighbors of each node that we have. So right now we have 5 nodes. So from 0, 1, 2, 3, 4. So these are 5 nodes. Then let's store their neighbors. This is what we're going to do, and we'll store it as list. So we'll go through our prerequisite before, and then we'll check that 0 has 1 as a neighbor. So 0 has 1 as a neighbor, then 0 also has 2 as a neighbor, then 1 has 3 as a neighbor, then 1 has 4 as a neighbor, then 3 has 4 as a neighbor. So this is it. Now 2 and 4, they don't have any neighbors, so these are empty. That means these 2 nodes can be safely completed. These 2 nodes, you can complete them in any order. So, but we'll go through basically like in one order from 0 to num courses minus 1, so that we can mark the visited courses basically. So that's the order that we will be visiting our nodes. Okay. So there is one more thing that I'll create is a course map. And in my course map, what I'll do is I'll mark the node that I'm currently visiting as false in the beginning, just in case there is basically a cycle. And you'll realize, like, we'll basically change this example just a little to understand that. But before that, let's understand how we are going to visit this. So we're going to start visiting our node 0. So I'll have a for loop running from 0 to n minus 1, num course minus 1. So this is the node we are visiting. So I'll mark this as, let's say, being visited means I'm just assigning the color green here. So that means I'm currently visiting 0. Currently visiting 0 means then I'm going to run a DFS on it. Then because I'm visiting 0, so what I'll do is in my course map, I'll say 0 is basically false. That means it cannot be visited. Why? Because in order to complete 0, I have to complete all its neighbors. So in the beginning, temporarily, I'm marking it false. Then what I'll do is I'm going to start visiting all its neighbors. So first let's choose 1. Let's choose 1. So this is what I choose. And because I'm currently visiting 1, that means I'm going to mark it basically in my course map as false, because I haven't fully visited it, like it's being visited. Then in order to complete 1, I have to visit both its neighbors. Then I'm going to start with 3. So I'm going to start visiting 3 because I'm visiting it. I'll mark this also as false. And because I'm already exploring the first neighbor of 1, 3 has only one neighbor. You can see right here. Then what I'll do is I'm going to start exploring that only neighbor of 3. So I'm visiting 4 right now. So 4 will be marked false. I'll mark this false. And then I check what are the neighbors of 4. Well, 4 doesn't have any neighbors. So what I'll do is it doesn't have any neighbors. I'm going to assign true to it because this course does not have any prerequisite and it can be completed safely. All right. So I'll change this false value to true, and then I'll return back to where it was. This DFS was called from. So it was called from 3, right? It was called from 3. So that means 4 has been completed. So I'll just mark it done. Then I go back to 3. 3 doesn't have any more neighbors than just one neighbor, which was 4. 4 has been completed. We have completed that course. That means we can safely complete 3, and now we'll also change its value to true. That means this course has been completed. We have studied this course and we have completed it. All right, then 3 was called from 1. 1 has one more neighbor that we didn't explore, but you see this neighbor has already been completed. So I'll just check it in my course map that have you been completed basically in while we were visiting the neighbor of 1. Well, this was visited, so we'll do is we'll also mark 1 as visited because all its neighbors are visited now. So we'll mark this as true as well. All right, so we have marked that one true. So, and 1 is also visited, done being visited. Then we come back to 0. 0 has one more neighbor to explore, which is 2. So here I'm going to start visiting 2. Initially I'll mark that false. You remember the process. Well, this is a really important basically I would say flow of DFS, and I think it's used in a lot of problems. So I'm trying to visit 2, mark it as false. Then what I'm going to do is I'll basically check all the neighbors of 2. Well, 2 doesn't have any neighbors, so what I'll do is basically mark this true because I could have taken it in any order. I could have taken it earlier also, but I'll mark this as true. And then this is basically done. I visited this. Then I come back to 0. 0 is fully visited now because you can see I have visited all the dependencies, all the prerequisites of 0. So this is also marked as 0. Now I have course map, and while we were visiting all these nodes, we could keep a track as like num course, and if that DFS is completing that, within that for loop in num courses, completed courses we can call it. So we can then finally say that we can return completed courses is equals to num courses, right? Because num courses could be a lot, but completed courses might not be equal to all the courses that we were supposed to take, because there might be some courses that were stuck in loop, so we couldn't take them. Then this will return false, otherwise it will return true. Okay, let's understand what I meant when I said that there might be a loop. So let's say at this place we had an edge from 4 to 1. That means in order to complete 4 you have to complete 1. So that means we'll change this one as 4 to 1. Okay, so in this particular set of courses, while I was visiting 4 here, I'm gonna start exploring 4's neighbors, so which is 1. Now if I try to go to 1, I will see that I'm already visiting 1. That means that now I'm gonna keep going in this cycle. That means I'm stuck in this basically cycle, and I cannot complete any of these courses because all 3 courses are dependent on each other. That means I can never complete these courses. So that is why we'll have that this course, and in the beginning we'll mark these as false because they are being visited. The code is going to be super simple, and let's write it down right now. All right, so let's write our code. Now first thing is let's create our graph, which is like an adjacency list. So I'll just say graph. Initially let's just have here all empty list. So each course is going to have like an empty, you know what, I'm bored of using I. so each course has like it's going to have a list of neighbors. So for course in range num courses, and let's fill this up. So we'll do for I'm gonna say for A and B in prerequisites. This is because it has pair of values. Now A is dependent on B, so B is A's neighbor. There is an edge going outward to B from A. So what I'll do is I'll append B to A's list. Nice. So now we have basically with these 3 lines we have created our graph, and then we're gonna also have course map. Course map is just like it's gonna store being visited values. All right. So now and then one more thing is like completed courses initially 0. Right. Awesome. Or maybe you know what, these are well placed here. Now what I'll do is I am going to basically iterate over all the courses and see if we can basically finish them. So for course in range num courses, and then we'll run a DFS on it. A DFS will check if that course can be completed. So if DFS this particular course, that means we can visit it, and if it's visited, then I will increment the completed courses. Okay, now let's implement our DFS. And I think this is the best place. So for inner function, and return if this completed course is equals to num courses. All right. Now let's implement our DFS. So we're going to have DFS, which is going to take a course. This course, if this is already in my course map where I will be marking if these course could be completed. So if this course in my course map, then I'll just return the value, whatever value it already has. So this might be basically true or false. So return course maps value for this particular key. And as I said, I will be marking this for temporarily. I'll be marking this false. So I'll say false, and then for this particular course, I will have to check if I can complete all its neighbors. That's when I can fully decide that this can be completed. So what I'll do is for neighbors in basically my graph, I'm gonna take out for this course all the neighbors of course. So if this cannot be completed, if let's say the DFS on this neighbor returns false, then I will return false. Return false. Okay, or I could simply even say, to maintain the consistency, I can simply say return this value as well. This is also basically returning false, because currently while we were visiting all the neighbors, then we are saying that this neighbor cannot be completed, right? So we can return false or same value. So I'll just say false. Okay, otherwise what I'll do is, here that means I have visited all the neighbors of course, so I'll mark this as true, and then return this value. I'll return that value, which is true. I can also return true here. Now that will be it. Finally, I can just, this is where I am checking all the dependencies using DFS of any particular course, and this is where I called DFS. If DFS is returning true, that means I could complete that course, and I can increment my completed courses. And I'm actually going to do it for all the courses. And most of the time, I think here, if there are like a set of courses and there are dependencies, prerequisites and everything, most of the time I'll be returning the value from here, because this must have already marked them in my map. So map is like pretty useful for us here. So finally, I think that would be it. Let's zoom out and test our code. And yes, our tests are passed. Let's submit it. And yes, it's a 2. Okay, let's write the time complexity. Time complexity here is going to be basically I'm visiting all the courses, which is like vertex of this set of courses connected. It's a graph, and all the edges, because I'll be visiting all their neighbors. And then for space complexity at max, even like in my this graph or course map, I'm basically storing them all the nodes, right? I'm storing all the nodes. So even I think I'm storing that relationship as well, so I would just say v plus e. I don't know, it makes a difference. So this is also, it can be also said, or v is also still fine. Alright, so now let's go back to AlgoYogi, mark this problem solved, and see you guys later in the next problem. Until then, bye bye.